Rare black hole devour star. Astronomers stunned by cosmic discovery. Space breakthrough. A rare kind of black hole has been identified by astronomers, offering insights into cosmic structures. Using NASA's Hubble Space Telescope and Chandra X-ray Observatory, scientists have discovered a possible missing link black hole, NGC 6099 HLX1, located 40,000 light-years from the center of a distant elliptical galaxy in Hercules. This intermediate mass black hole, IMBH, is a long-sought class that remains elusive despite being too large for single-star formation and too small for supermassive black holes. Its significance lies in its potential role in galaxy evolution. Scientists believe IMBHs play a crucial role in galaxy growth, yet finding them remains challenging. A study led by Yi-Chi Chang highlights that extreme X-ray emissions from such objects indicate tidal disruption events, where a star is torn apart by a massive black hole. These events result in a hot, glowing disk of gas spiraling into the black hole, enabling telescopes to capture the phenomenon. Observations confirm that the black hole near NGC 6099 HLX1 has a temperature of 3 million degrees, consistent with these disruptions. Hubble Space Telescope data also reveals a cluster of nearby stars orbiting the black hole. If the IMBH is devouring a star, how long does it take to consume its material? In 2009, HLX1 was fairly bright, then became 100 times brighter in 2012 before dimming again in 2023. This suggests a dramatic tidal disruption event. Over time, astronomers note that the black hole may flare multiple times or exhibit a peak followed by a decline until it disappears entirely. Understanding the building blocks of giant black holes provides insight into their formation processes. One leading theory posits that small IMBHs gradually merge to form larger supermassive black holes, while another suggests they originate from collapsing gas clouds in the early universe. This discovery hints that galaxies may harbor satellite black holes outside their centers, orbiting far from the dense regions where supermassive black holes reside. If we find more free-floating IMBHs becoming X-ray bright due to tidal disruption events, this could signal a new era of observation. Similarly, a statistical analysis could reveal how many such objects exist, how often they disrupt stars, and how much growth occurs when smaller galaxies assemble. Scientists spot exceptionally rare black hole eating a star. Imagine discovering a cosmic phenomenon so rare it challenges our understanding of the universe. NASA's Hubble Space Telescope and Chandra X-ray Observatory, despite their age, continue to unveil astonishing cosmic secrets. Recently, these telescopes jointly identified an incredibly rare intermediate mass black hole, IMBH, in the act of devouring a star. Hubble and Chandra collaborated to observe NGC 6099 HLX1, a striking X-ray source seemingly originating from a dense star cluster within the massive elliptical galaxy NGC 6099, situated approximately 450 million light-years from our planet. Hubble has been instrumental in studying supermassive black holes, revealing that many galaxies harbor these colossal entities at their cores, with masses ranging from millions to billions of times that of our Sun. Conversely, Hubble also uncovered the existence of numerous smaller black holes, with masses less than 100 times that of the Sun, formed from the demise of massive stars. However, there is a mysterious middle ground: intermediate mass black holes. These elusive IMBHs, neither excessively large nor overly small, often evade detection because they don't consume as much gas and stars as their supermassive counterparts, thus emitting less detectable radiation. IMBHs typically come into view only when they're actively feasting our star. When these IMBHs twin-sieve a star in a tidal disruption event, they emit a surge of radiation, NASA explains. The newly identified IMBH, NGC 6099 HLX1, was spotted about 40,000 light-years from the center of NGC 6099. In a recent study published in the Astrophysical Journal, researchers Yi-Chi Chang, Roberto Soria, Albert K.H. Kong, Alistair W. Graham, Carol A. Grishin, and Igor V. Chilingarian detailed their discovery of unusual X-rays in 2009. Chandra data.
They further investigated using the European Space Agency's XMM Newton Observatory. These extreme X-ray sources are rare outside galaxy nuclei and are crucial for identifying IMBHs, bridging the gap between stellar mass and supermassive black holes, says lead author Yi-T Chang from National Tsinghua University, Taiwan. NGC 6099 HLX-1's X-ray emissions reached a staggering 3 million degrees, consistent with a tidal disruption event. Hubble data indicated a small star cluster surrounding the IMBH, providing a rich food source. These stars are astonishingly close, separated by mere light months, or about 500 billion miles. The IMBH reached peak brightness in 2017 and gradually dimmed until 2023. If the IMBH is consuming a star, how long does it take? HLX-1 was bright in 2009, 100 times brighter in 2012, and then dimmed, explains co-author Roberto Soria of NAF. We need to observe if it flares repeatedly or if it's a one-time event. NGC 6099 HLX-1 is a captivating subject because IMBHs might grow into supermassive black holes by merging with other IMBHs orbiting a galaxy's center. Alternatively, some theorize that supermassive black holes originate from dark matter halos in the early universe, rather than from the amalgamation of smaller black holes. If we're fortunate, we'll find more free-floating black holes brightening due to tidal disruptions. Statistical studies could reveal the prevalence of IMBHs, their star disruption frequency, and how larger galaxies assemble from smaller ones, Soria adds. However, these studies face challenges due to the limited field of view of space telescopes like Chandra and XN Newton. The newly inaugurated Vers C. Rubin Observatory in Chile, which scans a vast portion of the sky nightly, could significantly aid in identifying tidal disruption events, albeit in optical light. But here's where it gets controversial. Are these IMBHs the missing link in black hole evolution, or is there another explanation? What do you think? Share your thoughts in the comments. Image credits: Science, NASA, ESA, CXC, Yi-T Chang, National Tsinghua University. Image processing: Joseph de Pasquale at SDSI.
Astronomers discover elusive intermediate mass black hole in NGC 6099. A groundbreaking discovery in the cosmos, unveiling the elusive intermediate mass black hole. Imagine a cosmic monster lurking in the shadows, feeding on unsuspecting stars that wander too close. Welcome to the world of intermediate mass black holes, IMBHs, a class of black holes that have long remained a mystery to astronomers. But here's where it gets exciting. A recent collaboration between NASA's Hubble Space Telescope and Chandra X-ray Observatory has led to the discovery of a rare IMBH located in the distant NGC 6099 galaxy. This breakthrough finding, published in the Astrophysical Journal, sheds light on the elusive nature of IMBHs, which have been difficult to identify due to their relative lack of visible activity. The detected black hole, designated NGC 6099 HLX-1, was found in a compact star cluster, approximately 40,000 light-years from the galaxy's center, situated around 450 million light-years away in the Hercules constellation. But what exactly are IMBHs? As the name suggests, they fall between the well-known stellar mass black holes, which are typically up to 100 times the mass of our sun, and the supermassive black holes that reside at the centers of galaxies, which can weigh billions of solar masses. These IMBHs, weighing between a few hundred and several 100,000 solar masses, have long remained elusive. While supermassive black holes are known for their immense gravitational pull and high energy emissions, IMBHs are harder to detect due to their more modest size and lack of accretion material to generate observable radiation. The detection of NGC 6099 HLX-1 marks a significant milestone in black hole astronomy. According to Yi-T Chang, lead author of the study from National Tsinghua University, Taiwan, X-ray sources with such extreme luminosity are rare outside galaxy nuclei and can serve as a key probe for identifying elusive IMBHs. They represent a crucial missing link in black hole evolution between stellar mass and supermassive black holes. So, how did astronomers manage to detect this elusive IMBH? The answer lies in the observation of a tidal disruption event, TDE,
where the black hole captures a star and breaks it apart, releasing a burst of radiation that allows astronomers to observe the otherwise invisible black hole. In this case, NGC 6099 ATLX1 exhibited extreme X-ray luminosity, a clear sign of such a disruption event. The Chandra X-ray Observatory first detected an unusual X-ray source back in 2009, but it was only through detailed follow-up observations by Hubble and the Newton Space Observatory that the full scope of the event began to unfold. The luminosity peaked in 2012, becoming about 100 times brighter before steadily declining over the years. This observation of fluctuating brightness provides important data for astronomers studying the feeding patterns and energy output of IMBHs, and it helps refine theories about how those black holes behave when consuming stars. But here's where it gets controversial. The discovery of NGC 6099 HLX1 may also shed light on the broader question of black hole formation. There are two prominent theories regarding how black holes evolve. The first suggests that IMBHs may act as seeds for the formation of supermassive black holes. Through mergers with other smaller black holes, they could grow over time, eventually reaching the sizes observed at the centers of most galaxies. The second theory proposes that gas clouds within dark matter halos could collapse directly into supermassive black holes without first forming stars. So, which theory is correct? The answer remains unclear, but understanding the role of IMBHs in these processes is crucial. As Roberto Soria, co-author and researcher at the Italian National Institute for Astrophysics INAF, noted, "If we are lucky, we're going to find more free-floating black holes suddenly becoming X-ray bright because of a tidal disruption event. If we can do a statistical study, this will tell us how many of these IMBHs there are, how often they disrupt a star, how bigger galaxies have grown by assembling smaller galaxies." This raises an intriguing question. Could IMBHs be the key to unlocking the secrets of black hole formation and evolution? We invite you to share your thoughts and opinions on this topic. Do you think IMBHs play a crucial role in the formation of supermassive black holes? Or do you believe they're simply a stepping stone in the evolution of black holes? Let us know in the comments.